Welcome to Module 1, Section 1 of the Keystone Review. So in this section, we're going to talk about linear equations a little bit. You can use this video to fill in your notes if you miss the review session, or if we don't get to that part in the review session. So here we're looking at linear equations, and remember, it's any equation that includes constants, variables that are multiplied by a coefficient. So here are some examples of linear equations. Notice here we have an irrational number. We have an irrational number there. You can have irrational numbers in your linear equations. Don't be afraid of that. We've got some examples that are not linear functions. So something that has an x squared is going to be a non-linear relationship. That's going to actually give you a quadratic function, which, if you recall from class, will give you a parabola in shape. Anything where x is in the denominator is going to give you an inverse situation. So that's going to, again, be a non-linear relationship. Absolute value bars, remember, that gives you that V shape from the graph. So again, it's not linear, non-linear. Remember, linear is line R. And then we have the square root, which will also give you a non-linear graph. So as you're looking at translating some linear equations from words into the linear equations, think about words we use to represent addition, subtraction, multiplication, and division. So think about some of the words you might use or you might hear for addition. Something like total or sum or combined. Those are all words that will represent or indicate that you're going to have to use addition for your problem or equation that you write. With subtraction, think about those. Difference, if something's less than or fewer than, you're going to probably want to use subtraction in that situation. Multiplication, think about multiplication. We've got product, doubled, tripled, rates. If you're given a rate, that's probably going to indicate you want to use multiplication in your equation that you write. And then division. So if the problem is talking about dividing something into equal groups or everyone gets the same, or if you hear the word quotient or divided or shared, those are all going to be indications you probably have some form of division in your equation. So looking at the properties, you've got the addition property of equality, subtraction, multiplication, division, and distributive property. Your formula sheet will give you a sample or an example of the properties for additive property of equality and multiplicative property of equality. They won't give you the division or the subtraction, but again, they're pretty much the same thing for all of those. If you know, your teachers have probably told you what you do to one side, you do to the other. They will also give you an example of the distributive property. It will be set up this way. So don't be afraid to use your formula sheet and look back at that. If you're questioning a property or you forgot something, especially if they're talking about naming properties or asking you what property was used in this step, don't be afraid to look back at those. So recall, when you're solving an equation, and this is solving, we're not simplifying, you're solving, you want to make sure you remove parentheses first, collect like terms, and then isolate the variable. So that's kind of, the way we've worked with equations in the past, and it's important that you follow those, that order of operations there, trying to combine like terms, get the variable to one side, the numbers to another. Those are all things, again, use your intuition as you're working through the problems. So for something like this, when you're asked to solve, what value of x makes this equation true? So in this situation, we want to first, we don't have any parentheses, we don't have any like terms, so we want to get the variable, which is x, by itself. So in this case, I'm going to undo that, add 6 by subtracting 6 from both sides. if I subtract 6 from both sides, I'm left with 4x equals negative 32. Be careful with your integers. Make sure most students, when they make errors, are going to be in sign errors. So make sure you're keeping track of your signs and paying extra special attention to signs as you work through the problems. So here we've got 4x equals negative 32. So in order to isolate the x and get it by itself, I want to divide both sides by 4, and I'm left with x equals negative 8. Now, in this case, I can plug that negative 8 back into the original problem. 4 times negative 8 is, and then add 6 to that and hopefully get negative 26, which is true. So that would be my check there. So here are two problems we can look at in which you're asked to solve the equation. And it says here, one of the steps Jamie used to solve the equation is shown below. So think about what she did. She went from this to this, and she basically cleared the equation of the parentheses. So think back to that those properties that I just showed you. You can also look at your formula sheet, but what did she do? She eliminated the parentheses. Now, why did she do that? What property allows us to take that negative 5 and multiply it by the 3x and the positive 7, or the addition of 7, and results in this? And in this case right here, think about it, it's that distributive property. Okay? So we then are looking at another situation which you're asked to write an equation. So Jenny has a job that pays her $8 an hour plus tips. And they're giving you tips as T, okay? So if she works for 4 hours on Monday and made $65 in all, which equation could be used to find the tips? So remember, she's working 4 hours and she's making how much? She's making $8 an hour, okay? And then we're told she made $65 in total. But what's the missing piece? The missing piece is going to be her tips, which is T in this case. And we can see that, which equation represents what we just wrote? T. So here is a linear equation with two variables. And oftentimes when students see a problem like this, in our example here, solve the following equation in simplest form in terms of y. They think they have to find a number for y, and y has to be, say, 5. And it's not always the case. Why in this situation? Because we don't know what x is, we are not going to be able to tell exactly what y is. We can't identify it as a number. But we can rearrange this equation so we have y equals something. It's not going to look like what you want it to, but it is still solving. So in this case, our whole task is to get that y by itself, okay? Y equals. So the first thing I'm going to do is I'm going to subtract 4x from both sides, okay? So if we subtract 4x from both sides, here and here, what are we left with? Well, we are left with 3y, I'm not sure why that is writing that way, 3y equals negative 4x plus 9. Okay, so now the equation here asks us to solve for y, not 3y, not 4y, not negative y, but 1y. So our final step here is then to divide everything by 3 so that we can isolate that y value. And we will be left with y equals negative 4/3 x plus 3. And we have solved for y. So just remember that as you're doing the Keystone exam, just take your time and think about what it's asking for. The beauty of most of the questions, they'll be multiple choice. So you've got some answers that will help guide you if you're drawing a blank or you're stuck. So don't be afraid to use the responses to help guide you. So here's our sample question, and in this situation, they give us an ordered pair. And so we're purchasing hamburgers and hot dogs, and we've got $10 to spend. And if you start to dissect this equation, we can see here X is our hot dogs, and that 3 right there. Think about what that means, and think about what that 4 means. So in both of these cases, the 3 is going to represent how much a hot dog costs, and the 4 represents how much a hamburger costs. And there's our $10 we have to spend. So they're telling us that an ordered pair 2, 1 is a solution. What does that mean? Well, think about 2 represents your X value and 1 represents your Y value here. So what does that solution represent? Well, in this case, it is going to be the only option of B, that Franco purchased 2 hot dogs and 1 hamburger. Think about this. If the hot dogs cost $3 each, he would spend $6 on hot dogs and $4 on hamburgers, which is a total of 10. So understanding the problem, looking at your equation, and noticing what it represents is going to be vital for this solution. So in this linear equation here, we've got the 2 variables, the X and the Y again, and now we're talking about solutions to the equation. So if we look at this, they're giving us our domain of X's, okay? We've got 3 X's here, and they're asking us which of these points, or sets of points, is going to match this equation. So my first task here, I plug in 2 for the X. That gives me 6 minus 12y equals 6. So as I start to solve this equation for y now, okay, I end up getting y must be 0 when x is 2. So in this situation, the point 2, 0 is part of our solution set. Okay, so we can eliminate B. You then go about plugging the -3 in and the +1 in for x, doing the same process to find your other 2 solutions. So as I go through those, the only one that is going to work and has all 3 of the points is C here. Watch your signs with something like this.